Good evening, everyone. Am I audible, guys? If someone may confirm that. Darshan, and I guess Jyoti is here. Am I audible? Jyoti, Darshan, if anyone may confirm. Okay, I think I should wait for other students to come. I'll just wait for 5 more minutes and then I'll start the class. Okay, so I think I'm audible now. Hello. Krishan Kumar, sorry. If you may confirm that am I audible or not? Anyone? Okay, so you all can see the screen as well. Please confirm this. Okay, Jyoti. Thank you so much. So, good evening, everyone. Welcome to your Air Pollution and Control weekly tutorial session number 12. So, today we'll be discussing your questions for the assignment for week 12. And this is your last class as well. So if you are having any doubts or any type of questions or any topic that you want to discuss, we can take that in today's class because today we will be having your last class for this session. Okay, so let's start with the first question. The first question says, Which method is used in sampling and analysis of PM 2.5 in the ambient air? And your options are: first is gravimetric method, next we have improved West and Geck method, third is modified Jacob and Hochheiser method, and the last is UV photometric method. So for the sampling and analysis of PM 2.5 in the ambient air, which method you will prefer? Anyone? A. So Krishan Kumar has said gravimetric method. Correct. This will be your gravimetric method only. So let's have a look at this gravimetric method in a bit detail. What is the principle and how do we do that? So the for the sampling of PM 2.5, what it does is the sampler draws the ambient air at a constant volumetric flow rate, which is maintained at 16.7 liters per minute or 0.0167 meter cubes per minute. And this rate is maintained by a volumetric flow controller, which is coupled to a microprocessor into a specially designed inertial particle size separator, that is impactors. And here, what happens is the suspended particulate matter in the PM size ranges is separated 2.5 microns for collection on a 47 PTFE filter paper. So, see, simple if you say in the laboratory, how gravimetric method is done. For example, let's see, we have a sieve analysis. So what we did was, this was some sort of like arrangement for the sieve analysis. For example, sieving sieve analysis of the coarse aggregates or the fine aggregates. So different size of sieves were there. For example, let us say this was your 20 mm, then this was your uh, I'm giving just for an example point of view, 15 mm, then this was 10 mm, and this was finer than 10 mm. So what happened there, what we did was we just put the sample in here, and this sieve was placed on a shaker, and whatever the size, in this way the size segregation was done. Like the 20 part, aggregates would stick on this sieve, smaller size would stick on, would like get trapped on this sieve, and like 10 would get trapped on this sieve, and the finer ones will move downwards. So this was the sieve analysis that we did, and this is your basic gravimetric method. Now, in the air pollution, what we are doing is we are having the same principle, but what we are doing here is we have an inertial particle size separator, which are known as impactors. And we are using a, instead of these sieves, we are using a polytetrafluoroethylene PTFE filter paper here. And this filter paper is designed to collect the size of two particles of size 2.5 microns. And this is done over a specified sampling period. And what is done after that is each filter paper is weighed before and after sample collection, like before and after collection. Like same ways what we did here was we used to measure the empty sieves, and then the weight with the aggregates we used to measure, and then by subtracting the after weight after, like net gain जो आएगा हमारे पास, net gain will be equals to weight after minus weight before, and this will be your weight of the particles of size 2.5 microns. Now how does this apparatus looks like? This is your fine particulate sampler for the size of two. to 2.5 micron particles, or PM10 and PM2.5. It collects that. This is your inlet. This is PM10 impactor. This separates the particles of size PM10 and passes let the smaller size particles to pass on further. This is your filter paper holder. Here your filter paper is placed. Now here we also have dry gas meter. A vacuum pump is there to suck the air stream. Like, vacuum pump is there to let the air come enter from this inlet, and then when this air stream passes this uh, from this filter paper, what is done here is the particles of size 2.5 microns or more get stuck on the filter paper, and the smaller size of particles move in the downward direction. Now, what are the apparatus that is needed for this experiment? We have an electronic microbalance to measure this filter paper. Then we have a digital timer or stopwatch for monitoring the sampling period, for to find out the duration of sampling. Then we have filter paper support cassettes and covers to place this filter paper, because we can't place it on any no, normal surface, because it may also have some amount of particulates present on it, and those may get stick onto that filter paper. So we need these support cassettes and covers. Then plastic containers, relative humidity or temperature recorded, and other apparatus or materials that are given in the CPCB manual. So, what is the sampling procedure here? 47 dia PTFE filter paper with the polypropylene support ring manufactured by Wattman or equivalent, having 2 microns pore sizes. So the pore size of this filter paper is 2 microns. That is why uh, it is trapping the particles of size 2.5 microns or higher, and it lets the smaller size particles to pass on from it. The filter paper should have very low background concentrations for ions and elements. Now, next is filter paper inspection and conditioning of filter papers. So, uh, first of all, we need to visually inspect all the filter papers for holes or the cracks. If any paper has any kind of deformity or holes or cracks, we need to remove that. Now, note down the batch in the log sheet. Label all the filters which would be unique to represent a sample. Then we need to put the marked filters in the Petri dishes. These are sterilized Petri dishes that we use in the laboratories. Always use proper forceps made of non-reactive material to handle the filter paper. You can't just hold it with your hands, because our hands are also carrier of these particulate matters. Prepare a sample tracking sheet for each filter paper. Then, for the conditioning purposes, to minimize the particle volatilization, aerosol liquid water bias, filter papers must be equilibrated for 24 hours at constant relative humidity, that is 45 plus minus 5%, and a constant temperature between 25 plus minus 2 degrees centigrade. And the why do we need to be this equilibrize the filter paper? Because these intend to minimize the liquid water associated with the soluble compounds, and also to minimize the loss of volatile species that may be present in the particulates that we collect on this filter paper. And this need to be done before and after the sampling process. Next is just that after your experiment is done, uh, first, to start the experiment, take out your conditioned filter paper from the plastic petri slide and filter paper containers. Then we need to weigh the conditioned filter as it is. Then record and store it in a laboratory coded filter paper cassette. Then follow the same procedure for the exposed after sampling filter papers. Once we record the values, then we need to put these filter papers onto the air samplers, And then while the sampling is done, after that we need to follow the same procedure. And then the mass of the PM 2.5 is recorded in the data sheet and logbooks against respective filter paper numbers. So this is how we did gravimetric method for the uh, analysis of PM 2.5 in the ambient air. Now, for the next question, the filter paper used during the sampling of PM 2.5 in the ambient air is known as PTFE filter paper. And this PTFE refers to option A is polytetrafluoroethylamine, then polytetrafluoroethyl, polytetrafluoroethylene, and polytetrafluoroethanol. Anyone? Jyoti, Krishna is saying B and Jyoti is saying C. Okay, Krishna is also saying C. Polytetrafluoroethylene. Yes, this is the full form of your PTFE filter paper. Now, moving towards the next question. The absorbing reagent, potassium tetrachloromercurate, TCM, is used in the sampling and the analysis of option A, SO2, option B, NO2, option C, carbon monoxide, and option D, ozone. NO2. Okay. Jyoti is saying NO2. Anyone else? Krishna is also saying B. Okay. So it's correct. This will be SO2, not NO2. This sulfur dioxide from the air is absorbed into a solution of potassium tetrachloromercurate. And this complex is stable to strong oxidants such as ozone and NOx, and therefore the absorbed solution may be stored for some time prior to analysis. This complex is made to react with para-rosanilene and formaldehyde to form the intensely colored para-rosanilene methyl sulfonic acid. And the absorbance of the solution is measured by means of a suitable spectrophotometer. So the measurement of this SO2 in the ambient air, this sampling process is based on the principle of uh, absorbance and scattering. Basically, we use spectrophotometer, to measure the absorbance of the solution, and then I guess a calibrated curve is plot to find out the concentration of SO2 in the air. So, what are the instruments that are required? First is your analytical balance. Then we have a vacuum pump that is capable of maintaining an air pressure greater than 0.7 atm at the desired flow rate, and a calibrated flow measuring device to control the airflow from zero point 0.2 to 1 liters per minute. Then an adsorber, that is oil glass midget impinger, is required. Spectrophotometer is required, which is capable of measuring absorbance at 560 nanometers, equipped with 1 centimeter path length cells. So the qubit that we use in the spectrophotometer, these have 1 centimeter path length. Glasswares that are low actinic glassware must be used for the analysis. These are the reagents and the chemicals that are required for this sampling process. First of all, what we do is we place 30 ml of absorbing solution in an impinger and sample for 4 hours at the flow rate of 1 liter per minute. After sampling, we measure the volume of the sample and transfer it to a sample storage bottle. Basically, this absorbent that we are using or the absorbing solution that we are using, this is placed in an impinger, and this impinger, what it does, it absorbs the gas onto its surface, and this is a type of a liquid solution. Then after sampling, we measure the volume of the sample and then we transfer it to a sample storage bottle. After that, we replace any water lost by evaporation during sampling by adding distilled water up to the calibration mark on the absorber. And then we need to mix the solution thoroughly and then pipette out 10 to 20 ml or 10 or 20 ml of the collected sample into a 25 ml volumetric flask. And after that, onto this volumetric flask, we add 1 ml of 0.6% sulfamic acid and allow reacting for 10 minutes to destroy the nitrites resulting from the oxides of nitrogen. We don't need to measure, we don't want to measure any kind of nitrites or nitrates into that solution. So we let it, we add sulfamic acid and we let it allow to react for 10 minutes to destroy the nitrites. After that, we add 2 ml of 0.2% formaldehyde solution. We add 2 ml of 0.2% formaldehyde solution and 2 ml of para-rosanilene solution. And and we make the solution up to 25 ml with distilled water. If we took, like for example, we took, this is our flask. This is your 25 ml of flask, for example. We took, initially we took 20 ml of the sample. Then we have added this 1 ml of sulfamic acid. Then 2 ml of formaldehyde is there and 2 ml of para-rosanilene is there. And after that, if during these reactions or during transferring, if any amount of liquid is lost, then we make this total solution 25 ml by using by adding distilled water. Then we need to prepare a blank in the same manner using 10 ml of unexposed absorbing reagent. Let's say initially it's 10 ml, then it would be easier to understand. 10, 1, 2, 2. This will be 15. Then we add 10 ml of distilled water. Now I guess you can understand how the sample is prepared. It's in the same manner. We'll be preparing a blank solution, and instead of using 10 ml of this absorbent sample, we will be taking 10 ml of unexposed absorbing reagent. And after a 30-minute color development interval and before 60 minutes, measure and record the absorbance of samples and reagent blank at 560 nanometers. Use distilled water, not the reagent blank, as the optical reference. So this is how we measure the absorbance, and the formula for the concentration of sulfur dioxide, to find out that we have this formula, that is As minus Ab, which is multiplied by Cf is multiplied by Vs divided by Vx into Vt. So what are these values? AS is your absorbance of the sample, and AB is your absorbance of the reagent blank. CF is your calibration factor, which is your reciprocal of the calibration curve slope. Then we have this will be your VA. VA is the volume of air sampled, VS is the volume of sample, and VT is the volume of alicate taken for the analysis. So this is how we can calculate the concentration of sulfur dioxide in the ambient air. Now, next question is, modified Jacob and Hawkeiser method is used for the sampling and analysis of option A, carbon monoxide, option B, ozone, option C, SO2, and option D, NO2. Anyone? Why do we use this modified Jacob and Hawkeiser method? Okay, so this is used for the sampling and analysis of NO2 in the ambient air. So what is the principle of this sampling method? The ambient nitrogen dioxide NO2 is collected by bubbling air through a solution of sodium hydroxide and sodium arsenite. We take this solution and we bubble out the air through this solution to collect the ambient nitrogen dioxide. The concentration of nitrite ion produced during sampling is determined colorimetrically by reacting the nitrite ion with the phosphoric acid, sulfanilamide, and N1-naphthyl ethylene diamine dihydrochloride (NEDA), and measuring the absorbance of the highly colored azo dye at 540 nanometers. So basically, once once we have bubbled out this solution and collected the NO2 in this sodium hydroxide and sodium arsenide solution, then need to uh, we need to find out this absorbance. We need to measure the absorbance of. We need to prepare an azo dye with this solution. So for that, we react the we let it to react with these chemicals that are given here, that NEDA and this sulfanilamide and phosphoric acid, and then we measure the absorbance of the highly colored azo dye with the at a wavelength of 540 nanometers. For this SO2, the wavelength was 560 nanometers, and here we have the wavelength as 540 nanometers. The instrument or equipment that are required for this experiment are, first is your analytical balance, then we have vacuum pump to suck the to maintain a constant flow of 1 liters per minute through the sampling solution. Then we have an absorber, a midget impanger. Then we have spectrophotometer, which is capable of measuring absorbance at 540 nanometers. Now, then we have some glasswares. So what is the sampling procedure that we do here is place 30 ml of absorbing solution in an impanger and sample for 4 hours at the flow rate of 0.2 to 1 liters per minute. After sampling, measure the volume of the sample and transfer it to a sample storage bottle. Then replace any water lost by evaporation during sampling by adding distilled water up to the calibration mark on the absorber and mix thoroughly. Once the sample is prepared, then we pipette out 10 ml of a, now we have a 50 ml volumetric flask. This is what? 50 ml. We pipette out we pipette out 10 ml of this sample into a 50 ml volumetric flask. Then pipette 1 ml of hydrogen peroxide solution. This is H2O2. 10 ml of sulfanylamide and 1.4 ml of this NEDA solution. Sulfanylamide. And with thorough mixing after the addition of each reagent and rest, what we do is, let's see, this is your 50 ml mark. So rest we fill this with distilled water. This is how we create the sample. And in the same manner, we prepare a blank solution using 10 ml of unexposed absorbing reagent. And after a 10-minute of color development interval, we measure and record the absorbance of the samples and the reagent blank at 540 nanometers. And samples with absorbance greater than 1 must be reanalyzed after diluting an alicate of the collected sample with an equal quantity of unexposed absorbing reagent. And then the formula is for the concentration of CO2 is AS, that is absorbance of the sample, minus AB, absorbance of the blank, which is multiplied by your calibration factor. Then this is multiplied by VS, volume of sample, divided by volume of air sampled, multiplied by volume of alicate taken for the analysis, and multiplied by 0.82, which is your sampling efficiency. So this is how we sample for an sample to find out the concentration of NO2 in the ambient air. And this is done by modified Jacob and Hawkeiser method. Now for the next question. Which one of the following procedures is used for sampling of the flue gas in a chimney for suspended particulate matter? Which of the following procedures is used for sampling of the flue gas in a chimney for your suspended particulate matter? Isothermal sampling, isokinetic sampling, adiabatic sampling, or your differential sampling? Anyone? B, isokinetic sample. Correct, Jyoti. This will be your isokinetic sampling. So the determination of particulate matter concentration, this consists of an isokinetic sampling of a measured amount of gas from the flue gases, separating the particles from the gas and determining the particulate concentration. So this is since we know that in the emissions of from a chimney, we have flue gases as well as some particulates present in that emission. So to separate out this particulate matter from the flue gases, we perform isokinetic sampling. What is isokinetic sampling? So basically, isokinetic sampling is the sampling at such a rate that the velocity and direction of the gas entering the sampling nozzle is same as that of the gas in the duct or stack at the same sampling point. So basically, why do we call it as isokinetic sampling? Because refers for the same and kinetic refers to the velocity. So we ensure that the sampling duct that we are using here, sampling nozzle that we are using here, we ensure that the velocity and the direction of the gas which enters the sampling nozzle is same as that of the gas which is there in the duct or stack from which we are measuring the emissions at the same sampling point. To ensure a representative sample, the kinetic energy of the gas stream in the stack should be equal to the kinetic energy of the gas stream through the sampling nozzle. So that is why this is termed as isokinetic sampling. Now, what is the sampling procedure here? First is your location of sampling sample. Okay, so sample for particulate concentration shall be done where velocity measurements were carried out. So from the point where we have done the measurement of velocity, at that point only we tend to find out the to take out the samples for the particulate matter. Then the size of the nozzle size. Basically, we need to select the nozzle size which provides a meter sampling rate between 40 to 60 liters per minute, and calculation of proper sampling rate. We need to calculate the sampling rate at the gas meter for each sampling point before starting the test. So to calculate this sampling rate, the formula here is VV, that is equivalent vapor volume of condensate at meter condition, that is equals to RS into Tm by Ts multiplied by P bar minus Ps divided by P bar minus Pm, and this is multiplied by Vm divided by Vm plus Vv. So these terms are explained here, and with this we can calculate your proper sampling rate. Now, how the sampling train is prepared? This is done like the sampling train is prepared as shown in this figure. From this stack, we have a heated probe with a, filter in heated box. Then we connect first impenger for condensation, and this may be filled with your some distilled water. Then we have silica gel impinger. Then we have a stack monitoring kit, and then dry gas meter is connected, and then a pump is connected with that. And second, we have pitop tube and the temperature measurement devices. A thermocouple is there, then a manometer is there, and in the end, we have a velocity measuring device that is connected. So after the sample has cooled down, we use a small brush to carefully brush the dust from the inside of the nozzle into the thimble, and then to transfer the thimble to the weighing room. Remove it and place it in a dust-tight container. And then we determine the dust collected in the thimble by weighing the thimble before and after the run and compare the weights. Dry the thimble in an oven for about 2 hours at 120 degrees centigrade before sampling to let any moisture to vaporize out. Then we cool and dry the thimble after the sample in order to weigh it with dust in the same condition as before sampling. So to calculate the volume of the gas sampled, we use the following equation. VA standard is equals to Vm into Y into P bar minus Pm divided by 760 of Hg. This is your pressure in mercury column. That is multiplied by 273 plus 25 degrees centigrade. Basically, we have converted this Tm into Kelvin. Now to calculate the dust concentration, we have Em equals to W2 minus W1, that is final weight minus initial weight of the filter paper. this is in grams multiplied by 1000 divided by standard volume of the dry gas through the meter. And the dust emission rate is calculated as EM into QS divided by 10 to the power 6 milligrams per hour. So this is how we perform the sampling of the particulate matters from the stack or a chimney. Now for the next question we have, to ensure a representative sample, which energy of the gas stream in the stack should be equal to the energy of the gas stream through the sampling nozzle? First is your thermal energy, then we have kinetic energy, then we have potential energy, and then electrical energy. So which energy should be equal? Anyone? Kinetic energy. Correct, Jyoti. Because just now we have read about this isokinetic sampling, and this is also talking about the gas stream in the stack. So this should be your kinetic energy. Now for the next question. For measuring the carbon monoxide and carbon dioxide using the indoor air quality measuring probe, the calibration should be performed at a time interval of at least. First is 1 month, next is 3 months, third is 6 months, and fourth is 12 months. And how much time interval should we calibrate the measuring probe? Anyone? 12 months. Okay, let's see. First, let us understand this air sampling in the indoor environments. First is multi-gas monitor. So basically, this multi-gas monitor that is used for the measurement of 5 parameters, and this is used for your sampling of indoor air quality. First is your temperature, then we have percent relative humidity, then is dew point, then we have carbon monoxide and carbon dioxide. So these 5 parameters can be measured by using your multi-gas monitor. And if we are having your advanced version of probe, then it can also measure VOCs, ozone, and hydrogen sulfide, H2S. So basically, this is how the equipment looks. We have a handheld personal computer. This is a type of a small tablet that we have that comes along with this multi-gas monitor. This is your measurement probe, and this is your adapter. So this is your probe software that is installed in this uh, that handheld personal computer, that is your tab. And also you need to install this software onto your laptop or desktop, any kind of computer that you have. You need to install this install it on your system for the transfer of data. Then we have these batteries, these D-type batteries. Basically like these are big size batteries that were used in your torches. So this is that kind of battery. So like how does this measuring probe looks? The measuring probe contains four fast response high accuracy sensors that provide measurements for five parameters. And this fully integrated system, this measures indoor air quality using a handheld personal computer running IAQ HPC software. So at any point where you need to take this sample or you need to measure these parameters of indoor air quality, you can just place this probe. You can grab this probe. You just need to handheld this probe and take it to whatever point where you need to measure the concentrations. Then to maintain this probe, what is there? How to maintain this probe? First of all, we need to store the probe in a cool, dry, and dust-free environment that is between 32 degrees and 70 degrees Fahrenheit, between 0 degree or 21.11 degrees centigrade respectively. If the probe is being stored for an extended period of time, we need to remove the batteries. If the probe gets dirty, wipe the outside with a damp, wet cloth. Do not attempt to clean the inside of the probe. For the cleaning of the inside of the probe, we can return it to the manufacturer for maintenance purposes. Avoid operation in the direct sunlight as relative humidity measurements may be erratic. Do not immerse the probe in water. If condensation forms on the CO2 sensor, the readings may be erratic due to temperature differences between the two detectors. Do not drop or subject the probe to vibrations because that may also affect the sensors that are present inside the probe. So what are the parameters that we get from this measurement probe? You can clearly see how the screen looks like of this software. This is your screen of this tablet giving out the readings, the temperature. It gives the temperature in Fahrenheit, degree Fahrenheit, relative humidity that is 50%, dew point is 55.3 degree Fahrenheit. Then we have concentration of carbon monoxide is zero point 0.3 ppm and CO2 as 789 ppm. So basically, this carbon dioxide absorbs light at a very specific wavelength where other gases do not absorb. So thus CO2 is measured using non-dispersive infrared spectroscopy. Carbon monoxide diffusing into the electrochemical sensor is either oxidized or reduced at the sensing electrode and coupled with a corresponding counter reaction at the other electrode, and the current is generated through the external circuit. So this current generated is proportional to the condensation of the gas concentration of the gas present outside the sensor. And the percentage relative humidity is measured by absorption and desorption of moisture by a thin polymeric film. As the relative humidity changes, the dielectric property of the film changes, and so does the capacitance of the sensor. For example, resistance over a platinum element is measured. Platinum sensors are highly accurate over a wide temperature ranges. So this is how we use this multi-gas monitor. I guess we have answered this question. So which of the following parameters is measured using the non-dispersive infrared spectroscopy in the multi-gas monitor? Hmm. I've taken this topic just now. Like this non-dispersive infrared spectroscopy. This is used to measure the carbon dioxide. No, the ninth question we have. The principle of the method involved in the measurement of particulate matter in a spectrometer is: first is scattering of light, next is gravimetric method, third is chemical method, and fourth is UV photometric method. Scattering of light. Okay, let's see. First of all, let me tell you how this device works. So this is your environmental dust sampler. This is your outer casing. if we need to use this sampler at to take the samples at the uh, ambient environment, or we need to take the sample where the humidity is relatively higher. So then we use this outer casing. This is your sample inlet for the outer casing. It has an heater pre-installed so that in if the humidity levels are quite high, it can heat up the air, and then the dry air sample gets into this spectrometer. This is your EDM, electronic dust monitor, or the GRIM spectrometer. This is your outlet cable that connects of your spectrometer to your PC or laptop, whatever you want. This is your memory card. Here, all the data is stored. This is battery, which is placed inside this spectrometer. This is your filter paper, 25 PTFE filter paper. This the dia of these filter paper is 47 millimeters. So, what are the different control elements of this dust monitor? First is your LCD display. Here the values we can set, like what size of particles we need to visualize, and then the readings are given here. We have a slot. This slot card is for data storage card. This is slot for this data storage card. Then we this is your keypad. From here we can control your this spectrometer. Then this is sample inlet. If we are not using the outer casing, this inlet works as the sample inlet. This is your analog input, and here this is your battery charger or adapter point, and this is RS-232 cable inlet point. So this is interface port. This is helps us to connect this spectrometer with your laptop or desktop, and with that we can transfer the data. Now for the back panel, we have this is your filter chamber with the bayonet lock. Here we place PTFE filter paper. This is your warning notice for laser. 11, this is your calibration label. This is your device less designation and a serial number. 14th is your locking feature for the battery case. And 13th is your sample outlet with the end cap. Okay, so what is the principle of method? So the measuring principle of the model is the light scattering of single particles. That is with a semiconductor laser as a light source. So inside this measuring chamber, the scattering light is being led directly via mirror with a wide opening angle onto the detector. The detector is positioned in the right angle to the incident laser beam, and this setup of the detector is denominated as 90-degree scattering light detection. So this is the principle of this method. Now, next question is the minimum time interval for monitoring of the particulate matter using the spectrometer software is 45 seconds, 30 seconds, 12 seconds, and 6 seconds. Okay. So let us see how do we use this spectrometer. So first is to change out the PTFE filter, we need to remove the old filter with tweezers from the filter holder assembly. We just open this filter chamber door and then remove the old paper. Then using a cotton swab, clean the inner walls of the filter housing. Weigh and record the weight of the new filter for improved accuracy. Weigh the filter 3 times and take the average. Place the new filter onto the into the filter housing, ensuring that overlaps the O-ring and 4 points are visible around the filter, and then carefully close the filter door and tighten the screw. There's a screw in the back side of this door. And this is how a filter paper is changed. Then how do we connect this to a spectrometer? The data can be displayed as particle concentration in the unit particle per liter count, and also as mass concentration in the unit micrograms per meter cube. So after installing the spectrometer software in the system, place the spectrometer in the field housing as shown in the figure. Connect the spectrometer with the system using the special RS-232 cable. Then this is how the user interface of the software looks like. So first of all, we need to go on this scan ports. When we press this scan ports to detect the connected devices and check for valid license file. If it's not detected, you can select the ports manually. Like this has selected the port as COM3. Then after that, we click on this port and that connect it connection to the device. Next step is to select the time interval. So the minimum time interval is 6 seconds and the maximum time interval is 60 minutes or 1 hour. We need to synchronize the device time with the PC time every 3 months when there is change in the time zone. So we can first we need to click on this get correct current PC and OPC time. Once we get this PC and OPC time, then we click on this set OPC to PC time. So all user settings and some additional information about the used device and program versions are stored in the header section of each result file. And these files are ASCII files spread in the spreadsheet format and can be opened after the measurement with this spectrometer or software with Excel or a simple text editor. After completing all these settings, all buttons of the control window should be activated. You can see earlier only these two buttons were active. Once your device is connected, then all the buttons of the control window should be activated. Then we click the start device button, and then to enable the data logging plus start data storage. So once we press this start data storage button, the data will be storage will be started. And this picture is showing the measurement in the 6 seconds time interval. And here you can see the particle counts are being generated. This is how the software displays all the measurement data according to the set time interval in the real time. And units are in counts per liter or micrograms per meter cube. So this is how your spectrometer, Grimm spectrometer looks like and works. So the minimum time interval here is 6 seconds. So with this, I guess we have completed all the questions for this assignment. If you guys are having any doubts or any queries, you can ask now, or any topic that you want to discuss, we can take that. Anyone?
Good evening, ma'am.
Jyoti, yes,
Hello.
yes. I'm audible to you. Hello.
Hello.
Yes. Jyoti, I have uploaded the earlier presentations as well on the portal, and this presentation I'll upload by today evening only. After this class, I'll upload this presentation along with this recording of the class. Any other doubts if you guys have? I guess Krishnan Kumar was trying to ask something. Yes, I'll.
मैडम ये आप पीपीटी कहाँ पे अपलोड कर रहे हो?
एक्चुअली हम हमारे पास एक स्प्रेडशीट आई है गूगल फाइल्स पे क्रिएट होकर के एंड वी आर अपलोडिंग एवरी पीपीटी एज वेल एज दिस अ लिंक फॉर द गूगल ड्राइव। तो हम वहां पर ये सारी चीजें अपलोड कर रहे हैं। डोंट यू गाइस हैव दैट गूगल ड्राइव लिंक? वहां पर सारी मीटिंग्स का रिकॉर्डिंग एज वेल एज दिस प्रेजेंटेशन जो भी पीडीएफ फॉर्मेट में है, मैं ये दोनों चीजें ही अपलोड कर रही हूँ वहां पर।
तो मैडम वो ड्राइव की लिंक हमें चैट बॉक्स में भेज सकते हो कि मेरे पास तो नहीं आई है अभी।
अच्छा, ओके। जस्ट वेट फॉर अ सेकेंड, मैं वो ड्राइव का लिंक शेयर कर देती हूँ। जस्ट अ सेकेंड। This is the link from my drive. Yeah. Okay. I have shared the link for the Google Drive, and you can see that.
ओके मैडम, थैंक यू।
Any other question or any other query that you have?
और मैडम एग्जाम में मतलब किस पीपीटी में से पढ़ेंगे तो आएंगे कि फिर हम असाइनमेंट पढ़े तो उसके रिगार्डिंग आएगा?
सी पीपीटीज तो आपको पढ़नी ही पड़ेंगे। देयर इज नो वे यू कैन स्किप दैट, बिकॉज बेसिक कंसेप्ट्स तो वहीं से बिल्डअप होंगे। और अगर एक बार अपने पीपीटी अच्छे से पढ़ रखी है तो असाइनमेंट के क्वेश्चंस तो आई गेस इतने इजी होते हैं दैट यू कैन डू इट ऑन योर ओन। मतलब वो तो बहुत इजीली हो जाते हैं। बहुत बेसिक क्वेश्चंस ही होते हैं आपके असाइनमेंट में आई गेस। तो अगर पीपीटी आपने अच्छे से पढ़ी हुई है और जो भी बेसिक कंसेप्ट्स है वो आपके क्लियर है, सो देयर इज नो वे कि असाइनमेंट के क्वेश्चंस आपसे ना हो पाए। तो आई वुड सजेस्ट कि पहले आप प्रेजेंटेशंस को पढ़ लो, स्लाइड्स को अच्छे से गो थ्रू करिए, और आई थिंक एक दो बारी पढ़ने के बाद में यू विल गेट टू नो कि व्हाट आर द इम्पोर्टेंट टॉपिक्स, या कौन से लेक्चर्स है जिसके कंसेप्ट ज्यादा इंपॉर्टेंट है कंपेयर टू अदर्स। फॉर एग्जांपल जो केस स्टडीज है वो एक तरह से एक सैम्पल स्टडीज है, उसके कंपैरिजन में जैसे जो प्लूम मॉडल्स है या लैप्स रेट की है या आपके पॉल्यूटेंट्स जो पॉल्यूशन कंट्रोल डिवाइसेस है, ये टॉपिक्स ज्यादा इम्पोर्टेंट है।
ओके मैडम, थैंक यू।
Okay. Anyone else? If you're having any other question?
Will you conduct another class for revision or this is the last class, ma'am?
Sorry, Harsha, actually, this revision class couldn't be conducted because today they told me, like yesterday only, they told me that today is the last class, and I was planning to conduct this class on Wednesday, but from tomorrow onwards, we won't be allowed to conduct any class because we'll be getting our TA-ship certificates by tomorrow only. So whatever we have to do it by today only. So if there's any topic or any question that you guys have, you may ask in today in this class itself.
Yes, ma'am. Ma'am, lecture 59 talks about multi-gas monitor, ma'am. So that means that monitor is monitoring multiple gases. So what is the meaning?
See, just now I've discussed this multi-gas monitor. Basically, uh, the basic version of this multi-gas monitor, it measures two gases, that is carbon monoxide and carbon dioxide. Let me get into that. Yeah, this you can see this. It has two gases, that is carbon monoxide and carbon dioxide. But if we are having an advanced probe, that it can also measure gases, for example, your VOCs, your ozone, and hydrogen sulfide as well. So these are the gases that can be measured. Basically, it is a type of a sensor-based equipment. You just need to place it from at any point from where when you need to take the readings or monitor the indoor air quality, and you'll get every single value in your this tablet, or if you connect this tablet to your desktop or system, then you can transfer those values into your laptop or desktop as well. So this is a very simple type of apparatus.
Thank you,
Yeah.
ma'am.
Yeah. Any other questions? Anyone? Um, I guess you guys don't have any further questions. Okay, Jyoti wants any suggestions for the exam. See, Jyoti, I would suggest you to focus on the basic concepts for the exam. For example, how do we say? Like, see the pollutants, basically the pollutants and their sources. For example, let us take that. So, you should be knowing the sources of each and every pollutant, and it will be both for ambient as well as the indoor air and environment. And also, as far as I know, and as far as I have observed the previous trends, few topics are not very much important, and few topics are very important. For example, you will definitely have a question from the lapse rate. You will have a question from mixing height. You will be having a question from Gaussian plume model, I guess, and also from your mm, pollution control devices. Then theoretical question you can expect from indoor air pollution. So these are the important topics, and might be possible that one or two question will be given from your case studies, or the initial slides that we have. For example, impact of this air pollution on climate or vegetation, or the global and regional uh, episodes of air pollution that we have. So you need to have a basic idea about each and every topic, but also I would suggest that study those topics in like in a detailed manner, because definitely they will be there in your exam. And rest, the exam will be very much not that much difficult. It will be easier. You'll be having MCQ type of questions. So I guess, yeah, you can do that. Any other questions, guys? If you have, please ask. How to solve the numerical questions just by applying the formula, I guess. Like, the basic method that I also use for solving any type of question, that first of all, like, write all the data that is given in the question. Then like, write all the data that is given in the question, whatever the data that is given. Then write down what is asked in the question, what to find out. Then we have whatever the formulae to find out those values, and try to like, many times like, it's possible that, like, for example, the formula for Gaussian plume model is that C is equals to Q divided by pi u sigma y sigma z e raised to the power minus h square upon 2 sigma z square. For example, we have this formula. So sometimes they can directly ask you the concentration, but sometimes what will happen is they may ask you this effective height of this stack. Then how you will approach for this? You will start from this basic formula. Then you just simplify this formula. Like, for example, how to get into this. First, we transfer this into left hand side. So C into pi u sigma y sigma z. This comes downward, divided by Q. That is equals to your e raised to the power minus h square divided by 2 sigma z square. Now, to simplify it further, what we'll do is we'll take natural log on both sides. So ln of c pi u sigma y sigma z divided by q. This will be equals to minus h square divided by 2 sigma z square. Now multiply this with minus sign, so this will get removed. Then transfer it to this, so minus of ln c by u sigma y sigma z divided by q, and this is multiplied by 2 sigma z square, that is equals to h square. And to remove this h square is 2, 2 sigma z square, h square. So finally, to find out this value of h, we have minus of ln c pi u sigma y sigma z divided by q multiplied by 2 sigma z square and whole raised to the power 1 by 2. So this is how you find out the values of certain terms in your questions. Any other question if you have?
हेलो
Yes.
मैडम, इसके अंदर कितने परसेंट न्यूमेरिकल आएगी, उसका कुछ आइडिया आपको मैम?
See, न्यूमेरिकल्स का परसेंटेज वाइज तो मैं नहीं कह सकती हूँ, बट हाँ डेफिनेटली theoretical questions will be more as compared to your numerical questions, because इस सब्जेक्ट में हमने मैक्सिमम पार्ट जो कवर किया है दैट इज थ्योरी पार्ट ओनली, and also for the MCQ it's easier to give theoretical questions, but definitely numericals will be there. I'm not saying कि numericals आएंगे ही नहीं, but अगर proportion wise compare करें तो I guess theoretical will be more.
ओके मैडम.
Hmm. Okay guys, any other questions or any other doubts? So I guess this was it for your last class. All the very best for your exam. And also, I would like if you guys may give some kind of feedback for this class, or how did you like this class? Please do share your feedback in the chat box only. And yeah, so all the very best for your exam. And I'll just end the class. I hope you guys are not having any doubts still. If you are having a, okay, let's fine. It's fine. Let's wait for 5 more minutes and then I will end this class. Because if you may have any doubt, then we can take that now only. Okay, so see, guys, I'm also not very well today, so I'll just end the class now. All the best. Take care. Bye bye.
Thank you, ma'am.
बाय.
Okay, take care, guys. Do share your messages in the chat box because I would like to see your comments on this class.